Hi, I'm Kendra Little. I'm a DevOps advocate for Redgate. And in this video, I'm going to talk about how Dynamic SQL can help you solve some tricky problems in terms of automating changes for your databases. I'll be showing migrations in this demo using Redgate's SQL Change Automation for source control. And what SQL Change Automation does is it lets you use incremental migration scripts to apply and automate your database changes, while also giving you a state-based view of the database. So while showing this tool, I'm going to talk about some use cases where I think Dynamic SQL can make a lot of sense. And then we'll also step back and talk about some times when Dynamic SQL does not necessarily make sense and some pitfalls that I think that you should avoid. Like anything else, I think Dynamic SQL can absolutely be amazing, and we have to use the force wisely, because anything that can be amazing, if used wrong, hey, turns out we could actually make it terrible too. So let's go ahead and dive in. I've got my demo environment here, and I am starting out in the master branch, but the way I have my repo set up, I have to develop in feature branches because I've got some automation there. So we're going to just say we want to do a new branch, and let's just go ahead and name it feature dynamic SQL there, right? Go ahead, and when I do this, I'm going to go ahead and check out the branch, making it my current workspace. And I can see down here that, in fact, my new branch, feature dynamic SQL, is my current branch. Now, after I create a branch, the thing I like to do is think about, am I using the right database for my development environment? So on SQL Change Automation, when I open that pane in Visual Studio, I can see what am I currently using as my development database, and I can change it if I want to. So if I might need to work in multiple branches, maybe I want to use a different database for different branches so that if I need to change back to another one, I haven't messed around with that database. I could totally do that. But in this case, I'm going to go ahead and use pubs_dev. So the first thing I'm going to do is just refresh to make sure that that database environment is in sync right now with my code base. And now SQL Change Automation, it says we've got 42 objects in sync. I don't have any objects in the database that don't match source control or vice versa. So got a good place to start off. And the way I'm going to author this change, I want to do a dynamic SQL change here. The way I'm going to author this is I'm going to go into my migrations folder here. And, I'm not doing a particularly great way of batching my changes. You can totally customize the way you use these folders and the way you account for your changes. I've got a really rough and ready one here, but I'm going to add a new migration script into the compellingly named 1.1.1 more changes folder. So I'll just right click and say add new item. There are many ways to do this. Like if I wanted to do a change not using Dynamic SQL, I could make changes in my database and then import them, right? This is just one way to do it. But I want to just create a migration script from scratch because I want to use a snippet that I have created with SQL Prompt. And if I just type the word create, I named my custom snippet create index online, and we can see a little bit of a preview here. Snippets are fantastic for any patterns that you might use repeatedly where you want to save a lot of typing. So let's take a look in the snippet manager. So I'm going into the SQL prompt menu here and then into the snippet manager. And if I scroll down and look at the snippet I created and click edit, what I set this up as is some T-SQL that first off checks what addition when this migration script runs. And it will run both when I'm, refreshing here in my development environment, as well as if I use this snippet in a migration script to the final code in that migration script, it'll be run whenever this is deployed, as well as when the code is built. So the first thing it does is check the engine edition using server property. This returns an integer that we can use to determine, is this enterprise or developer edition? And that's what I care about in this case, because in this example, what I want to do dynamically is, let's say I want to create a non-clustered index, right? I want to create a non-clustered index, but let's say when I deploy this, I'm going to deploy this to some SQL Server instances that allow online index creation, that are enterprise edition, but I also might need to deploy it to some instances that are standard edition that don't include the ability to do online indexes. And you might wonder, well, when would that happen? there are some patterns when this happens. So one common pattern that's out there is we might have a single code base that we have designed so that we are deploying it to an environment where each of our customers has their own database, right? So we have one single code base, and then different customers each have an individual database. And when we apply changes, we have to apply it to all those individual databases. Now, if we have this pattern where we have a single tenant per database, when we have a production environment for this, one thing that also often happens is some of the customers are like really important big customers, and we might have enterprise edition for production for those customers. But other folks who aren't as active, don't do as much business with us, they might be on a more affordable standard edition instance, right? So in that scenario, it's attractive. We've already paid for enterprise edition. Let's use this feature of creating the index online when we can, which it's not 100% online, but it does mean less locking, less contention, etc., right? So this is essentially what we're saying is whenever we can, we are going to add the with online equals on clause to this index. But, we're using Dynamic SQL because we know this isn't going to always be the case. And in those cases where it's standard edition, we cannot include the words with online equals on in our syntax, because if you try to do that against standard edition, it will just fail. And it'll say, no, you can't do that here, right? So we want to handle that implementation detail of how the index is created with Dynamic SQL here. All right, so I'm going to go ahead and click cancel here because we were just looking at the snippet setup there. And let's go ahead and use our index. So if I start typing create, then highlight it and hit enter, it will populate my snippet into my migration script. I used some placeholders in that snippet. They were surrounded with $signs. So I'm going to fill them out here. So I want to give my index a name. And I've just kind of given myself a guideline about a reminder about what my naming convention is here. So I want to do this on let's look at the table we want to create this on. Let's say I want to do this on the jobs table. And let's say I've already determined that I want to do an index on min LVL. So I'll go ahead and say I want this on dbo.jobs and I want this on min LVL. Now I can customize this to my heart's desire. So let's say in my snippet here, I've made room so that if I want to add includes here, that's defaulted in my name and definition. But let's say for this one, I actually don't need any included columns on this. I can, of course, delete and customize this to my heart's content. So I'm going to remove the word includes because this just has one key column. I, as a SQL Prompt fan, always like to do Control-K, Control-Y to reformat my text before I save with my preferred style. And now I've gone ahead and saved this off. So now I have a migration script that has this dynamic SQL in it. And I've got an indication that this is pending deployment here, right? The script has not yet been deployed. And I can go ahead and click Deploy Project to run this script against my development database. And you'll see that I have, in customizing my command, messed up the syntax here, right? So I've left in an extra semicolon. And when I reformatted this, I didn't think about my dynamic SQL. Here is the offending semicolon. But this is what I really, I want to discover these issues early, right? I want to test this as much as I can. So I'm going to go ahead and remove that now. And now let's go ahead and say, now let's deploy this there. And let's see if I did better in my dynamic SQL. Sure enough, I did. And because in my snippet, I included a raise error statement, similar to print, I'm just using it not to actually throw an error, but just to print, I actually had it print out the syntax that I used there. That's this little part of the code I've got there. All right, so this has been deployed, but there's more to do. This has been deployed to my development instance. There's more to think about here, and we need to refresh because if we look at our environment over here, we can see that here's my new migration script. That's great. You can rename that file if you want, but that's our new migration script. But let's look down here at the offline schema model. What SQL Change Automation does for you is it maintains an offline schema model of your tables. This is very, very useful because I want to know at this time, what is the state of the jobs table, right? This migration script is just an incremental change that will create a non-clustered index. But it's also incredibly useful to know what columns are in the job table, what other indexes are on there, etc., so that when I'm merging this branch back in, we can detect, is there a merge conflict with something else? If all I was doing was tracking these migration scripts, it would be really hard to detect conflicts when I merged in. So it's important that these things be updated, but notice there's no indication that this file has been updated. And let's open that jobs.sql folder. Or not folder, it's a file. Notice on here, there's no sign of that new non-clustered index. We have a primary key that is a clustered index, but that was already there. I'm not changing that, right? We've got constraints, etc. Now, look at this note at the top. This file contains a read-only view of your schema. So the point is not, I do not edit this file. Like, the point is not for me to go in and look at this file. But it says any edits to this file will be overwritten during the next import. Well, I didn't do an import. I just manually added a migration script, but no worries. Check this out. The tip is to just be a constant refresher. So if you go to the SQL Change Automation window and you click refresh, it will go have a think about your migration scripts and about your offline schema model. And hey, now there is an indication of a change on the jobs table. If I open up the jobs table, yes, when I clicked refresh, it thinks about, hey, let's check out the offline schema model. Let's check out this and make sure it's correct. And it will look at your migration scripts and bring those in. So I think this is very, very cool that even though I'm using Dynamic SQL in migration script, even though I manually created that, I mean, from a snippet, but I manually created that, we are still able to keep that schema model up to date. Very, very cool. So, and this helps me detect merge conflicts and all of that good stuff. It also can help me compare, right? Let's say I want to compare the state of a branch with a database or with another branch. These files in the offline schema model help make sure that for the tables, I can do that. Programmable objects help us do it for other things like functions and stored procedures. All right, so let's take a look at the changes we're going to commit. I'm going to click on the little pencil in Visual Studio, and I'm going to say created index with dynamic online clause there. I'm going to go ahead and before I click commit, we can see that what has actually changed is our new migration script is there. And jobs.sql has been changed, and then our .sql proj file has been updated to reflect the other changes that I've made here and here. All right, cool. So I'm going to go ahead and click commit all there. And now I need to, since I'm using Azure DevOps here, I need to sync to share my changes with the server. So we are now pushing this up to Azure DevOps. And we're going to go ahead and go in there and do some things to watch the progress of this and make sure it works. Now, while I'm opening up Azure DevOps, let's talk about when does Dynamic SQL not make sense, right? So I've just used the Dynamic SQL to say, okay, only do this online when you can. That makes sense because the key here is thinking about what is actually part of the schema and what is not part of the schema. Saying create the index online, whether or not the index was created online is not a part of the schema in SQL Server. It's not tracked as part of the schema. It's like if you look at an index later and you want to know, hey, was that created online or not? Actually, pretty sure there's not a way to find that out unless there's some undocumented way to find that out. It's really just an implementation thing about how the index is created at the time it's created, but whether or not you create an index online or offline, the definition of the index is the same either way. For things that will change the definition of schema permanently, you want to be really careful about Dynamic SQL. So if, for example, let's say we still have this example of we have one code base, but then we have one database per customer. Let's say we had an example where, customer A over there, we want one extra column in a table for customer A. And for customer B, they don't need that extra column in the table. Be very careful handling that. I would not handle that one with Dynamic SQL because we want our schema model to match what is in production because we want to detect merge conflicts. We want to compare. We do not want the column or table definition to be dynamically created at deployment time because then what we have in source is only going to match some parts of reality or maybe no parts of reality depending on how we've written the Dynamic SQL. If what you need is different schema and different databases for the same code base, instead of Dynamic SQL in the code that creates those, instead of that, what I would look at is using something like synonyms. So that if customer A really needs a different table than customer B, honestly, you could put the column in customer B and then just not put data in it. That's another option too. But another thing you could do is give the tables different names and use a synonym that is dynamically set in different databases to point at, okay, this is the right table for customer A. So I might have a synonym named dbo.jobs, and then customer A might have a table named dbo.jobs customer A, whatever you want to name it. In other databases, it might be named something different, but we use the synonym to point at what is reality for this customer. So that way, everything in production is, we have the schema represented in our code base. We can compare, we can detect merge conflicts, etc. So use the force widely. Dynamic SQL can be very cool, but you don't want to make your schema model useless. All right, so I have now gone up to Azure DevOps and I'm in my repo here. I'm in my repo for pubs, and let's make sure that I've committed this. I didn't actually properly push there. I didn't click that button right because I still have that notification that I have one unpushed commit there. So now that I've actually pushed that commit up, if I refresh on my repo, I get a nice notification, which I think is very convenient, that, hey, by the way, you just updated this branch. Perhaps you would like to create a pull request. So let's go ahead and create our pull request. And I'll just do very simple create here. And the way I have my repo set up, I have a branch policy that says whenever anyone does a pull request, we want to automatically run a build and validate this code. So this kicks off the extension from SQL Change Automation that is going to go ahead and build my code and validate it. And as that build progresses, if I want to watch it, I can watch it. So I can click on here if I'm, either the person who did the pull request or if I'm named as a reviewer, I can watch the agent job and click in there and look at what it's doing. So right now it's working on building the project and then it's going to go ahead and complete. This helps validate my Dynamic SQL. But it's only like the way that my Dynamic SQL is set up, it says, hey, check the addition and then form your addition based on that, right? So it's not going to check every use case for the Dynamic SQL. It's going to check the addition of the build server and use the appropriate Dynamic SQL for that. So if I look in the output of my build here, I will be able to see that it's successful and what happened there, right? But wait, there's more. I have some more automation set up in here. If I go on back to my pull request here, let's find my pull request. There's another step happening. And this can be very useful to the change reviewer as well. I have it set up to automatically clone an environment and do a deployment to it so that the pull request reviewer has a real environment to work in. And if I look in here, what I actually want to look at is now it's already created the clone database and it's deploying from the release artifact. But one of the things I can tell from the logs, we're going to go ahead and skip a step because I know where it is. But if we looked in the logs, what we could tell is I have it creating something called a release artifact and then exporting that. So our change reviewer or myself can go look at the release artifacts and look at some reports about the changes. And that way we can see what are all of the changes that are being deployed to this. Now, the way I have this set up, it's creating a clone that is from a recent sanitized production backup, right? Pubs is not a real production environment. So this, is like a fake production environment, but it is going to identify, hey, I cloned this off, and it's going to look at where I am in my branch, and it's going to say, I'm going to bring you up to date with this. So it will deploy any changes that I made in my branch, but also any changes that other people have committed that were merged into wherever I branched off of that haven't been deployed to that, right? It will bring it up to current date with where I am in my branch, including, anything that came before my branch that doesn't happen to be in here yet. So I can see what all those differences are. I can see if there's any compare warnings, and I can see the exact script that was run against it. So if I search for online, I can see that here is exactly the code in my migration script that was run, right? So if you're curious, does the Dynamic SQL stay Dynamic SQL? Yes. The code in your migration script is the code that's deployed, and this is the real strength of using migration scripts. A migrations approach allows you to highly customize this code so that the exact behavior that you want is the behavior that you get. I hope that this video talking about Dynamic SQL in migration scripts, when they make sense and when they don't, I hope that this has been helpful, and I'll see you in another video soon. Bye, folks. I'm Kendra from Redgate.